look at an example in section 8.1 where we actually want to estimate the mean for the population when we don't know anything except the sample mean, but we do have the population standard deviation. So here's an example from our textbook you can follow along with. So it says that Allen's hummingbird, it's a type of hummingbird, has been studied by zoologist Bill Ather. A small group of 15 Allen's hummingbirds have been studied in Arizona. The average weight for these birds is X bar equals 3.15 grams. Based on the previous studies, we can assume that the weights of these hummingbirds have a normal distribution, which has a standard deviation of 0.33 grams. So a few things for us to notice already. We have a normal distribution, we have a mean weight given to us, and we know the size of the sample, 15. The standard deviation of the population, not just the sample, but the population is given to us. So let's see the 4 questions we're asked to consider. We would like to find an 80% confidence interval for the average weights and answer what is the margin of error. B, under what conditions could we make these calculations? C, give a brief description of your results in the context of this problem. This means sort of translate your answer into English. And D, the second part of this section where we want to go the other direction to find the number of hummingbirds, the sample size that should be studied if we would like to be 80% confident that the error is no more than 0.08. So let's look at the first question, A. Well, we want to be 80% confident, so C is 80%, which is 0.8. We want to look at that table. We calculated this one already in our first video, but we could just also look at the table to see that ZC is 1.28. The error is that ZC times the standard deviation of X bar, right? Sigma divided by square root of n is the standard deviation X bar. So we put in those numbers for ZC, for sigma, and for square root of n. So let's look back at our question. We found sigma, ZC we found just above, and our 15 is our n. So take out your calculator and see that you do indeed get this. Make sure that in the denominator here you're taking the square root of 15. You're just taking the square root of 15, not your entire answer. So you can pause the video and check to see that you get 0.11 as well. So that's our error. Now we'd actually like to find the interval in which we estimate mu lies. So mu is between X bar minus E, this should again be bars, and X bar plus E, our error. So we've just evaluated our error. So let's just calculate that. X bar minus E, 3.15. Let's look back at the question. Here's the mean given to us. So 3.15 minus 0.11 is 3.04. What about X bar plus E? You add them, you get 3.26. So this is our answer. That's all you had to do, is say that the mu mean is between 3.04 and 3.26. So what conditions are necessary for our calculations? How are we able to do this? Well, we're told that the distribution of x is normal. We're given that. And we're also using sigma. Sigma is known, so we can find the error using this formula. Remember, if it wasn't normal, if n was at least 30, then you could get away with this anyway, because then X bar would still be normal or normally distributed. And in place of sigma, you can use you can use S, the standard deviation of the sample. But in this case, we know that X is normal and we have sigma, so no need to do anything extraordinary. What is our third question? Give a brief interpretation in the context of this problem. So this is like at the end of the last example. How do we want to say this in English? We're 80% confident that the average weight of the hummingbirds is between 3.04 and 3.26 grams. So now we're looking at a slightly different problem with the same setup. We'd like to find the sample size. So we're looking for n. In this case, we would like to be 80% confident with a maximum level of error of 0.08. So here is our C, and they're giving us the E. So we have a formula for our value of our formula for n. So C is 0.08, so our ZC, again, is 1.28. The error is given to us in this case. We use the same standard deviation as before. So here's the formula from the previous video, which we derived. So n is the square of this quotient. The quotient has ZC sigma in the numerator and the error E in the denominator. So again, check that you get this same 27.8784, etc., when you calculate this with your calculator. So remember, n is a sample size. So here we can take a sample of size 25 or 26 or 27 or 28, etc., but we can't take a part of one sample. So in this case, since we're not at a whole number, we're going to round up. So we're going to use 28. So what is this part D showing us? That in order to get that 80% confidence interval for the average weight of the hummingbirds to be only 0.08, we need a sample size of at least 28. And we could have guessed that it was going to be more. Previously we had a sample size of 15. And let's look what our error was. Going back up here. Our error previously was 0.11. Much bigger than the 0.08 that we're aiming for now. So with a bigger sample, we're able to get the error down to 0.08. We're still 80% sure of our answer though. Okay, so now that you've seen these 4 little videos, take a look at the Blackboard concept check just to see that you're on track, and you can bring in the homework. We'll look at that on Monday. Take care.